Hi everyone. Today's tutorial about unsigned binary numbers. Now, signed numbers use sign flag or can be distinguished between negative values and positive values such as plus 10 or minus 10. Whereas unsigned numbers stored only positive numbers but not negative numbers. So normally when we do binary calculation, by default, we treat it as a positive numbers. So number representation techniques like binary, octal, decimal, and hexadecimal number representation techniques can represent numbers in both signed and unsigned ways, whether it's positive or a negative binary number, which I'm going to show you that in a minute. Since there's no sign in binary or sign in bit in this unsigned binary number, so the n-bit binary number represented called magnitude only. So 0 is also unsigned number. This representation has only one 0, which is 0, which is always positive, by default positive. So one complement or first complement, as it is also termed, is another method which we can use to represent negative binary numbers in a signed binary. So in one's complement, positive numbers, also known as non-complement, remain unchanged as before with the sign magnitude numbers. So sign magnitude representation. So the representation of decimal numbers in everyday business is commonly called the sign magnitude representation. In this system, a number consists of magnitude and a symbol, which indicate whether the magnitude is positive or negative. So let's have a look at this example here. So we can see 0011, which is a 3, because 1 plus 2, that's 3. Okay, so for us to determine this is a negative, so that last bit here, we just change it into a 1. So that is the my negative 3, which I'm going to show you in the next slides how we do this calculation. So if we look at here, 7, so we have here 4 bits because it's 1, 2, 4, 1, 2, 4, 8. As you can see here, 4 plus 2 is 6, 6 plus 1 is 7. So the last digit here, we change it into a 1 to make it minus 7. And the same here, if we look at the 0, so 0 is 0, 0, 0, 0. And then if we change it to 1, 0, 0, 0, that is basically minus 0. So let's have a look at the one complement representation in this example using gates as well as basic here binary. So we have this 0, 0, 1, 0, 1, 0, 0, 1, or we can go 1, 0, 0, 1, 0, 1, 0, 0, because when we do calculation, we do the calculation from the right side. So what we do with the first complement, we invert it. What that means, we switch the binary into the negative, because as you can see here, this is the not of this OR gate. Yeah, and we can do that the same with the AND gate. So as you can see, the 0 becomes 1, 0 here becomes 1, 1 becomes 0, 0 becomes 1, 1, 0, here 0 becomes 1, 0 becomes 1, and then 1 becomes 0. This is first complement. So if I take these numbers, I just put them in here, as you can see. So we start 0, 1, 0, 0, 1, 0, 1, 0, 0. We got them from here. As you can see here, I started here by adding another 0 to the left side, which I'm going to explain to you in a minute why I've done that. Because here the 1, the two zeros, and then 1 again, the 0, and then 1 and the two zeros. And we know here we assign them to the decimal. So you can see 1, 2, 4, 8, 16, 32, 64, 128. And then I added that 0. So this in binary, this binary number in decimal is 148. Okay, and I want to show you in a minute how we do to convert into negative number. So we first complement, we invert the binary. So the 0 here becomes 1, just like I explained earlier here. The 0 here becomes 1. The 1 becomes 0. The 0 becomes 1. 1, 0, 0 is 1, 0 is 1, 1, 0. And then I added another 0 here and then changed it into 1. Why I've done that? Because it's 148 in decimal. 148 is more than 128, but it's less than 256. So I need more memory here. Yeah, that's why I added that, because if it's 128, then I will stop here. Yeah, maybe I would also add that just because later on I will need it for my negative. Okay, so that's why here I added 256. So I'll have 1, 2, 3, 4, 5, 6, 7, 8, 9 bits. So then we can see that it is very easy to find the ones complement of a binary number n, as well as we need to do simple change the ones to zeros and the 0 to 1 to give us the n equivalent. So that's why we did the NOT gate here to invert it. So if now we're moving on to the two complements. So if you look here from the previous example, the one for a decimal, which is basically here, this is the number, and then we invert it, that is first complement. Now I'm moving on to the two complement. Okay, so what I do in order for me to move to the two complement, I add 1 to it here, as you can see. So now 1 plus 1 is 10, or 0, 1. So 0 carry 1. 1 plus 1 is again 10, which is 0 carry 1. So 1 and 0 is 1. That comes down. 0 comes down, 1 comes down, 1 comes down, 0 comes down, and 1 comes down. That's the one I added earlier, the 0. So as you can see now, how do I know I've got this in binary is minus 148. So how do I know that? To make sure I've got the right number. So what I do, I know this one here is 256. Yeah, so what I do, I add the minus to it, 256. Remember when earlier I said we change the 0 into 1 to use it as a sign, as a negative sign. So we do minus 256 plus, I can't use the 128 because I'm trying to get the minus 148. So what do I need to do here? I go after the 1 here. 1 comes so under 64. So minus 256 plus 64. I didn't use the 0 here from 128. So I use 1 from the 64 plus 64. And then plus the 32. And then I jump to the 8 plus the 4. And that would give me minus 148. Let's do another example. So here I have this example, which is 21. Now 21 is more than 16 but less than 32. So I stop at 32. So 21 in binary is this here, as you can see. Yeah. So 1 0 1 0 1 0 0 1 0 1 0 1. So I invert it. So it becomes 0 1. So the 1 becomes 0, the 0 becomes 1, 1 becomes 0, 0 becomes 1, 1 becomes 0, and 0 becomes 1. This is my first complement. Now I'm going to move on to the second complement. Plus 1. So 0 plus 1 is 1. And then everything else comes down. Now you can see it's minus 21. How do I know that? So I know that 32 minus 32 plus 8, because that's what 8, because it's not 0. I can't use the 16, it's the 0. Plus the 2 here, plus the 1, and that would give me basically minus 22. I put here 3, but it's actual, what I mean here is 2 and 1. So 8 plus 3 is 11. 32 minus 11, we have 21.